Chemical properties of benzene. There are specifically 3 points we will be talking about. The first one is electrophilic substitution reactions. Within electrophilic substitutions, we will be talking about 5: nitration, halogenation, sulfonation, Friedel-Crafts alkylation reaction, and Friedel-Crafts acylation reaction. Then we will talk about the mechanism of this type, electrophilic substitution reaction, which is very important. Then second, we will be talking about addition reactions, and the last, third one, combustion reactions. So remember, chemical properties of benzene, these 3 points: electrophilic substitution reactions, addition reactions, combustion reactions, out of which electrophilic substitution reactions are very, very important, and 90% chances are that you will be asked a question from this particular point. Okay. Second and third are important. Obviously, you have to know because questions appear, but 90% possibility electrophilic substitution reaction of benzene. So first one is nitration. If we talk about, in nitration, what happens? We use concentrated HNO3 and concentrated H2SO4. The point here is that nitration can be done with concentrated HNO3. Then why do we use concentrated H2SO4? The reason is because to produce the nitronium ion. Okay, remember it is electrophilic substitution reaction, so there must be some electrophile generated. So the electrophile generated here is nitronium ion, which has positive charge. Actually, H2SO4 and HNO3 reaction is required. This is something I will be talking about in the mechanism later on when I talk about electrophilic substitution reaction mechanism. So you need to remember that when benzene gets reacted with concentrated HNO3 and concentrated H2SO4 at 323 to 333 Kelvin, nitration is done. Means this nitronium ion will replace the hydrogen which is there, and we will get nitrobenzene. This is a type of electrophilic substitution reaction. Next is halogenation. Similar to nitration, halogenation is again similar one. We get chloronium ion. Okay, in this case, for example, if we are using chlorine and that replaces hydrogen, so reaction with chlorine in presence of anhydrous AlCl3. When I will discuss the mechanism, in that case you will see the function of AlCl3, why we are using AlCl3. Okay, in this case hydrogen is replaced by chlorine, so chlorination, we get chlorobenzene. However, if we have the electrophile in excess, means chlorine is in excess, and the condition is that we need to have dark and cold atmosphere, then the reaction will be different. Okay, then all the carbons can get chlorine, so further substitution reaction can take place and all the hydrogens can be replaced by chlorine, so we can get hexachlorobenzene, C6Cl6. Next one, sulfonation. Fuming sulfuric acid is actually so concentrated sulfuric acid that one molecule of H2O is removed from 2 molecules of H2SO4. So oleum formula is H2S2O7. Okay, normally it is not actually sulfuric acid. Oleum is a different compound, but we can say it is highly concentrated sulfuric acid. Why? Because if I take 2 molecules of H2SO4, 2 molecules of H2SO4 will be H4S2O8. Now if you remove H2O from this, from 2 molecules of H2SO4, so you had 4 hydrogens, removed 2, it will be H2. S2 as it is, O8, you remove 1 oxygen, O7, so you actually get oleum. So oleum is considered as removal of 1 water molecule from 2 molecules of H2SO4. This is also known as fuming sulfuric acid because fumes of sulfuric acid appear when you use it. So this is written as H2SO4SO3, which is fuming sulfuric acid. However, it is H2S2O7. Memorize this reaction. In this case, hydrogen is replaced by SO3H. Again, electrophilic substitution reaction, and we get benzene sulfonic acid. This is known as sulfonic group. Next, fourth one, Friedel-Crafts alkylation reaction. Remember, we are talking about electrophilic substitution reaction. So here what will happen? The alkyl group will replace hydrogen. So that's why it is known as alkylation reaction. It was given by Friedel-Crafts. So that's why Friedel-Crafts alkylation reaction. When benzene is treated with an alkyl halide in presence of anhydrous aluminum chloride, AlCl3, alkyl benzene is formed. Means hydrogen is replaced by alkyl group. This is the reaction. So benzene is treated with methyl chloride. So this methyl group will replace the hydrogen from here. You get toluene in this case. If you want ethyl group, obviously you will use C2H5Cl. So this group will replace hydrogen. You will get ethyl benzene in that case. And many times this is an indication that we are talking about Friedel-Crafts alkylation. 90% times I would say it is an indication if you see in the reaction. Not always, but 90% times. Next reaction. So here, as I said, if you want C2H5, just use C2H5Cl, C2H5 will get attached and hydrogen will be removed. Next, Friedel-Crafts acylation. Acylation will be by acyl group. Acyl group, for example, CH3CO, this is acyl group. In general, acyl group will be this one, RCO. RCO is acyl group. So if you have RCOCl, it is acyl chloride. Okay. If you have RCOBr, it is acyl bromide. Okay. So acyl halide, for example, here in this case. Or it can be done by anhydride, acid anhydride also. Anhydrides have the formula RCO whole twice O, means there is again acyl group. So this is anhydride formula. So either we can use acyl halides or acid anhydride. In both cases, acyl group will replace hydrogen and we will get acyl benzene. So the reaction here will be like this. Here I am using acetyl chloride. Acetyl chloride is an example of acyl halide. This is acyl group RCOCl, and this group will replace hydrogen from here and will get attached COCH3. This is known as acetophenone. Another example, but here with acetic anhydride. So we can use acetic anhydride. I have already told you what is the form of acetic anhydride. This is acetic anhydride of RCO whole twice O. This also has this acyl group. So this acyl group will again replace the hydrogen here, will get attached here. So same compound you will get acetophenone. The only difference will be that instead of HCl, now you will get CH3COOH, acetic acid. So that completes the electrophilic substitution reactions of benzene. The second type of reactions under chemical properties of benzene, addition reactions. In these reactions, replacement will not happen. This is not substitution reaction. In these cases, addition will be done. It means the pi bonds will break and something will get added. So first one, if we talk about the reaction with hydrogen, that is hydrogenation in presence of nickel, it is reduction. But normally in this case, it will happen if we have vigorous conditions, that is high temperature and pressure. So in such cases, if we get benzene reacted with hydrogen in presence of nickel, which is normal reduction technique, the only difference here is that high temperature, high pressure required, we get cyclohexane. Now in this case, all the pi bonds are broken. So this is non-aromatic compound. So the conversion is from aromatic to non-aromatic. Another example, this is addition reaction, remember. In this case, we have 3Cl2, but the condition UV ultraviolet means HNu, we can say here 500 K high temperature. Then all the pi bonds are broken and chlorines get attached. So hydrogen is still there. This is CH, 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 everywhere this is CH, okay. And then because pi bonds have been broken, chlorine has got attached. So how it is different from the other chlorination substitution reaction? In that case, what happened? We had 3Cl2, but the condition was dark and cold. In that case, it remained benzene, okay, and then hydrogens were replaced by chlorine. All hydrogens were replaced by chlorine. So these two compounds are different compounds. Conditions are different. If we have UV light 500 K, then benzene hexachloride is produced. If we have chlorine in dark and cold, then hexachlorobenzene will be produced. So hexachlorobenzene, this is hexachlorobenzene. Okay. And this one is known as benzene hexachloride. Although there is no benzene here, it is known as benzene hexachloride because it is obtained from benzene. That's why. Okay. Normally you will see it written as BHC, benzene hexachloride, or gamexene. NCERT terms it as gamexane, but the correct name is gamexene. Next one, third and last one, chemical properties of benzene, the combustion reactions. And combustion reactions, the generic reaction you should know, generic reaction for combustion of hydrocarbons is CXHY plus X plus Y by 4O2 gives you XCO2 and Y by 2 H2O. In case of benzene, we say it is C6H6. It means X is 6, Y is 6. Substitute these values. Okay. So we can substitute these values and we get C6H6 plus 15 by 2O2 gives us 6CO2 plus 3H2O. So all combustion reactions of hydrocarbons will follow this generic equation. So if you remember this one, combustion reaction you can write down of hydrocarbons. So that completes the chemical properties of benzene.